So the topic that I'm going to cover today, this is more of a security scanning tool for the infrastructure configs. Okay, it is relevant to us, like in our day-to-day job. We use this tool, but many of us may have not tried to understand how it works and why someone has implemented it, or why may be clear, but not how that is implemented. Okay, so if you guys can relate, you might have worked with Terraform, okay, or maybe Kubernetes or any other such configuration files, right? Okay, but do you know there can be some misconfigurations in it, and if we have not identified in our development stage or before you deploy it, that can end up exposing your environment to external world, which is not good. Okay, so here I'm going to cover one topic which is about Chekov. So Chekov is a tool which is used for scanning your infrastructure configurations. Like in this scenario, we are talking about the Terraform. Okay? It can also scan any misconfigurations for CloudFormation or any other misconfigurations, right? So let me go next. Okay, so let's talk about some of the security scanning. I mean the requirement of the security scanning tools and how it is going to work for here in this scenario GCP Terraform configuration, right? So very first thing is it should, I mean, it is kind of Chekov is a efficient security scanning tool. Okay, so it involves in identifying the vulnerabilities and the misconfiguration of a infrastructure as a code. Okay, so how it does, it is like a set of policies that is being created. So whenever it is going to perform those scanning for the configuration, it will look into those policies, identify whether it meets those policies or not. If it is violated, it will highlight it, right? It will raise a red flag for it. Okay. So this particular tool is quite efficient. It can very quickly scan all of those modules, those configs, and then identify whether all of uh, all of those configs are actually following the set policies or not. We'll cover how the policies are actually created. I mean, I will give some idea about it. Okay. Also, it performs the automated analysis. So automated tools like this Chekov is facilitating the comprehensive and efficient scanning of GCP Terraform configs. Okay. So again, that automation is done in a form of like you install that tool on your on your device where you are going to perform this analysis, the configurations, right? In current scenario where I'm going to cover with the help of demo as well. So we'll see how it is integrated with the GitHub Actions, okay, and how it does the those analysis along with it. Okay? And as we understand, it really helps in performing the continuous monitoring. So as it can be integrated with your CI/CD pipelines, it helps in continuous monitoring of your code, okay, before even it gets deployed in the environment. Okay, that's how it is able to perform the ongoing integrity and security concerns check, right? So all these are very high level understanding of how Chekov's work. Okay. Now, so it's not that we only have Chekovs as one tool. Okay. So there are other tools, other open source tools. So Chekov as well as TFSec and TerraScan. So these are all open source tools, okay, which helps in scanning the misconfigurations. So I tried to put together these three tools, okay, and did some comparative analysis for it. So on very high level, again, all of these tools are good for scanning your Terraform configurations as well as some other configurations as well here. But here we are mainly covering the Terraform configurations. So Chekov is again specializing in scanning the cloud infrastructure code. In the demo, we'll be covering for the GCP. It also helps, I mean, the TF set, which is uh, another security scanning tool. It again helps in analyzing your security assessment and providing the specific misconfiguration alerts. Okay. So there are again a list of policies which lets this tool figure out if any of the configurations are in good shape or not. Okay. Similarly, Terra scan as well. Okay. Now, some of the features and capabilities of Chekov tool, if we talk about. So very first thing is the policy as a code. So we create we implement the policies in the form of code, which helps in scanning the other code for policy violations. Okay, so that's where we say it as a policy as code. Okay, so we create the custom policies based on the certain defined policies. That again, for policy creation also there is a set of a group which sets the benchmarking or the beside the policy which has to be created. Okay, for so and so cloud platform, maybe so and so other infrastructure. Okay, so the policies are converted in the form of code which helps in analysis. Okay, again, Chekov supports multi-cloud. So the same tool can be used to scan the AWS, Azure, or GCP, even other cloud Terraform. Terraform or the infrastructure as code scanning. Okay, and at the end, after all this analysis is done, it is able to generate the right set of reports summarizing what caused the error, how it can be fixed. It is also give you the links for identifying how you are able to fix that, or in case you want to skip, you should be able to know, okay, these are the IDs for those policies which can be skipped if you don't want to implement it or ignore it, right? Okay, some of the use cases again. So in case of, like, let's take an example of Chekov. So it ensures continuous security and compliance enforcement for cloud infrastructure, by that minimizing the risk associated with any of those misconfigurations. Okay. Similarly, TFSec, it also helps in identifying those configurations, misconfigurations for the Terraform, and helps in reducing any of the vulnerabilities or unauthorized access to the environment. Okay, so how it does, like, it is able to identify and then fix that. Okay, and the last tool is the TerraScan. So even that also helps in reducing the enhancing the security posture and reducing the threat, you can say, the threat surface for any of your infrastructure. Okay, okay. So it was very quick presentation for the this tool. We'll be going with the demo in the next step. Okay, so in conclusion, by applying this combination of, so we can have a combination of these tools, which can cover the a lot of the policies that can be missed by one of the tool, right? So it can be covered by maybe if something is not identified by Chekov, it can be covered by TFSec or maybe the Terrascan. So using a combination of these tools can be a better approach instead of going with just one, right? And that's how you are able to mitigate any risk and maintain the robustness of the compliance with the industry standards. Okay, now let's jump into the quick demo here. So let's go with this particular repo. So let me launch it. Yeah. Okay. So this is one repo that I have created for demoing this. Okay. It can be also found over here. It's named GCP TF Compliance Kit. Okay. So basically this repo, what it does, what it contains actually. So we don't have too many files here. It is only for demo, so I have kept it very minimal. So here, if you see, under Terraform GCP, we have one main.tf file, okay, which is going to create, I mean, it should be creating a Google Compute instance, okay, with so and so parameters like instance name, type of the machine under which Johnny is going to be created, and the boot disk and other scenarios, right? The network interface as well, okay. And the other two files is meant for the output, the variable values, and the provider. So nothing much here, but mainly these we are going to scan it through the Terra, I mean Chekov scan, Terra scan, or maybe the TFSec scan. Okay, so now this is the code. It is going to be scanned by these workflows or these tools. Okay, so if I go with Chekov first, okay, so as soon as I commit any code into my repository, these workflows, so these are actually GitHub actions here. So these workflows are triggered, okay, as soon as I commit this code into my repo. Okay, so that's what it does here. On post to the main branch, it is going to be trigger. Okay, and then it will perform these steps. So if you see the job, it says that this is for the Chekov scan. I hope it is readable, right? Okay, I have enlarged it a bit more. Okay, so it is going to perform this the GitHub actions. So it will first of all check out those repository, check out for the Python modules, okay, and then it will install the Chekov tool, okay, for the further scanning. So once the Chekov uh, tool is installed, okay, in the GitHub runners, then this particular command will be run over the current folder itself. Okay, so Chekov -t for directory. So here in the root directory, it will say root directory as well as any of its subdirectory. It will look for the codes. Okay, any code can be there. In this scenario, we have the Terraform codes only. So there can be some YAML files with the Kubernetes as well. Okay, so that can also be scanned by it. So here it is going to look for this code and perform the analysis, and after that it will provide the updates. Okay, like a summary of it. So now similarly we have these other tools. So we have this Terrascan. Okay, apart from the first few commands, if you see again, this is also installing the Terrascan on the GitHub runner machines, right? The host on which the jobs are going to be run, and then it will perform the scan of the Terraform configuration. So Terrascan scan -i Terraform is going to take care of scanning those modules. Okay, and similar to that, tfsec. So tfsec is also installing the tfsec first, and then it is going to be run in the current directory. Okay, now I did run some of the I did committed some code earlier, and I can show you how it how it responded, right? So let me take this example of Chekov Terraform scan. So here if you see, some of the job failed, but some worked fine, right? Why? Because here, let me just take the very first example when I committed it for the first time. So updated this file. Let's see how did the job done. Okay. So if you see the steps here, it set up the job, perform the repository checkout, set up the Python environment for it, and then install the checkoff. And then later it is actually doing the analysis, like it is executing the command chekov-d in the current folder. Now, once it has executed, if you see, now it is summarizing the result, Terraform scan results, right? So if you see, there are 4 past checks, 4 failed checks, and there are a few skipped one. Okay, because in this case, this was very initial commit where I did not skip any of the violations, right? Any of the policies. So here, if you see, it talks about check this particular ID for violation of. So we should be ensuring to enable connecting to serial ports is not enabled for VM instances, right? That's the violation as for the code that we have in the main.tf. Okay, because if you see, it talks about the file name as well, and the line number on the file from where to where it is actually not following the required policy requirements, right? So that's also, it is helping me with the guide how I can actually understand it better about it and then fix it. So if I click on this itself, okay, so if you see, now it takes me to the documentation, okay, based on which the policy violation is identified, right? So here these documentations are actually used for performing those analyses. So if you see, it is from the Prisma Cloud policy ID. So this is the ID, then Chekov ID is given. So Chekov ID, that is CKV GCP-35, right? And the severity of the violation is also mentioned. So it's a severity as medium, can have a subtype, build, other parameters, right? So here, if you see, it is not only providing us the details of what was as a violation, but also a fixed for that also. So here, if you see, this serial port enable equals to true is what going to actually, I mean, as of now, it should be false, okay? But if you see here, argument, it says that serial port enable by default set to false, okay? So it should be set to false by default, but in our configuration, let's see what it says. So let me move it a bit. Yeah. So in our configuration, what we have here, let's go to the main.tf file. Okay. So we did not mention about it. I mean, we did not talk about it. So if you want to fix it, so we can either use these suggestions and update our code, like adding the metadata about serial port enable, that's equals to 2, or we can just keep it false to avoid any violation, right? So that should actually fix the code. Let me take another example of the same scenario, which will cover for other aspect as well. So here, not only for the very first one that we saw, but if I go down, there is one more. I mean, I think most of us may be aware of this concept. So here, if you see the violation for the CKB GCP 40 says that ensure that compute instances do not have public IP addresses. Okay, and that's many of us must be aware while working in our day-to-day job, right? So here, if you see, this is a common one, and here, if I want to actually fix this particular error, let's see what it says. Again, this is a medium severity, so it can be there or not. And it is talking about this access config. So access config is for enabling the public IPs, right? So probably just removing this should be fine if you don't need it. Okay. So generally we avoid it unless required, or else if you want to really, I mean, use it for our requirement. Okay. So what I can do is, instead of like uh, uh, trying to disable that, because I need to use it, right? I don't want to avoid using the public IP for the certain instances. Okay, I want to expose it. So the only option that I have is I can actually mute the those alerts or those violations, right? So in the config file again, if I go back here to disable this alert or this violation, I can use a skip command. Okay, this is how it is presented. Okay, so I have used checkov colon skip equals to this particular ID. Okay, so this is how now when I executed it next time, okay, it did not throw me an alert. So if I just go back and then show you for checkov Terraform scan, if I show you this particular commit where I had actually added a skip for all of those I mean violations, now it is fine with it. Okay, so if you see here, for all of those violations like CKB GCP 32, now I'm skipping that. Okay, so I skip this violation, right? Similar to that, I'm skipping the other vulnerability, I mean the other violations as well. So here there were too many violations, so I need to be having that understanding where I want to skip some violation, or I want to keep it, or I want to fix it, right? So that is how this tool helps us in I mean identifying that and then working on it as per the organization requirements, right? So it should also be um, I mean taking care of what the organization has a requirement. Like there can be some policies which may be okay with the organization, or they can be very strict that they don't want to violate any of those violations, right? So yeah, so that's altogether I can say about this setup. But yeah, let me just quickly also make some I mean commit here and then see if it passes some of these violations, right? So let's see, let's take this example of one of this file. Okay, and I was talking about this skipping, right? So if I just I mean remove this line and then execute it again. So let's see. So let me add this file again. Okay. Now let's see, this action should have triggered now. If you see here, so here in this scenario, we have, I mean, I have created three separate workflows for each set of tools. Okay, just to make it easy to understand, right? Okay, and also it's like easy to maintain as well if you want to work with either of these tools. Okay, so if you see, I mean, two has already failed, and now let me open this one, which is for, okay, so this is for TF-sec. We'll be looking for the one for Chekov, right? So in Chekov, let's see if it is able to pass all the checks or not. Ideally, it should not, right? Yeah, see if it failed. Now let's identify which particular violation it is not able to perform, right? So if you look at, yeah, okay. So here, if I remove that one, okay. So if you see here, it does says failed for this particular resource, line 1 to 26, okay, and this is the violation, which is for compute instances do not have public IP addresses. Okay, ensure that public IP is not enabled for the compute instances. Okay, that's how easily it is able to find it out. Okay, yeah. So that will conclude this demo.